By now you should be quite familiar with the basics of the bash shell and the Vim text editor. Now I would like to put these two together and show you something called shell scripting. So what is a shell script? Well, it is basically a file containing a sequence of bash commands. So usually when you do something in bash, let's say that you, for example, want to move a bunch of files to a certain folder and then rename those files according to a specific pattern, all of that takes several commands to accomplish. With a shell script, you can automate complex tasks by entering a sequence of commands that accomplishes this task, and then you only have to run the shell script and not type these commands every time you want to do something. These shell scripts can also include conditional logic, variables, and user-supplied options. So before I go ahead and get into it, I just want to explain some of these key terms because they are very important and they will come up a lot. So what is a variable? Well, a variable is essentially a piece of data stored in memory. It's not written to the disk, but it's something the bash keeps in memory as long as it is running. These variables can contain any kind of information, for example, numbers, pieces of text, or strings as they are otherwise called, file paths, or even the output of another command. You can also include conditional logic in your scripts, which means that you could specify that if something happens, you want to do this specific thing, or if something else happens, you want to run this sequence of commands. You can also include loops, which means that you could go through a list of items, and for every item, you want to run a command on them, or something like that. I also want to point out that everything you can do in a script, you can do on the command line, because a shell script is really just a sequence of written down commands. You can think of it as a piano roll. Everything you can do in the command line, you can also do in a script. To start making our first script, I'm going to create a folder called scripts, where I'll be putting all of them together. So mkdir scripts, and I'll go into that one. And here you can create a file with any name that has the .sh file extension. Now remember, in Linux you don't actually need file extensions to identify what they are, but it's nice to have that, and Vim will also pick up on the syntax highlighting if you include it. So I'm just gonna type vim hello.sh. And now you can just type in any bash command really, and when you play this back, it will run those commands. So to demonstrate, I'm just going to type echo hello there, and make sure you include these in quotation marks, that usually helps. And so I've saved it with :w. And now let's quit out of Vim and run that. So I will type bash hello.sh, and it will run that command. And then it will exit the script. So far this isn't very interesting, and I think I should add some functionality to highlight what you could do with bash scripts. So let's open that up again. And what I want to do is I want to prompt the user to type in their name, and then I want to display it back to them. So to do that, let's write the read command and add -p, which is an option that means I want to create a text prompt. And I will type, "What is your name?" and add a space there. And then you add the name of the variable where you want this information to be stored. I'm just going to call it name, like that. What will happen when it runs this script now is that it will first go to this command, echo hello there. Then it will go down to this line and find the read command. Then it will open up this prompt and save it in a variable called name. Up until this point, name does not exist. I could demonstrate this right now actually by creating a variable on the command line. So to create a variable, you just type in the name of the variable, a equal sign, and then the value of it. So let's just call this one my number equals 12. And then if I echo this number with a $sign, my number, and the $sign means that I want to print out the value of a variable, like that, we say 12. So this is what we're going to be doing essentially. The read command is going to create a variable called name, and then it's going to save that information. But to really verify that it actually does that, we should probably print out the name as well. So after that, it will say echo hello name. Nice to meet you. Like that. And now you see this here, name, will be substituted for whatever we type in. So I'm going to run bash hello.sh, We say, hello there, what is your name? I'll type in my name. And then the $name actually is substituted with my name. We could also include some conditional logic in this bash script so that depending on what I type in, it will do one thing or the other. Let's type in hello.sh and I'll create a new blank line just for readability. And let's create a prompt that asks me how old I am. And then if I am above a certain threshold, it will say one thing, and if it thinks I'm too young, it will say something else. So I'll type in read-p. How old are you? And I'll create a space there. Age. And then I want to say if I am older than 25, it will say, wow, you are really old. And if I am younger than 25, it will say, wow, you are a little baby, which is a gross exaggeration, but bear with me. So I'll type if, then 2 square brackets, and here we type in the condition. So if age dash greater than, this is what dash GT stands for, and then I'll type in how old I want to check against, which is 25, and then 2 closing brackets. Then you add a semicolon, which basically means I'm done with this statement now. Let's move on. Then. So if age is greater than 25, then I want to do something. In that case, I'm going to echo, wow, you are really old. And if I am not older than 25, so I'll just say else, it will echo something else. Go, you are a little baby. And then when you're done with every condition you want to check, you close it off with FI, like that. So let's exit out of Vim and run this now and see what it does. It will do the same thing as before. It will ask for my name, and then it will ask me how old I am. I am 26 years old, so I'm going to type 26. And it says, wow, you are really old, because it checked against that age that was now 26. But let's do this again and type something else. Let's say I'm 12. You are a little baby. So this covers the basics of how variables and conditional logic works. Already with these tools, you can expand these scripts into quite complex programs that can help you automate some long-winded tasks. The next thing I would like to show you is a concept called command substitution. I mentioned before in the introduction that you can actually store the output of a command in a variable. To demonstrate this, I would just create a short text file that we can work on. So I'm going to call this test.txt. And I'm pretty happy with this, so I'm just going to go and save that. And create a new script called reader.sh. So what I want to do here is that I want to store the first line of that test file in a variable. So I'm going to create a variable just called first line, and then the equal sign. And this is very important that you don't have any spaces between the variable name and the equal sign. Otherwise, you'll get an error when you try to run this. So what I want to store in this variable is the output of a chain of commands. So let's actually run that command first, just to make sure that it works. So if you remember the cat command, you can use to just print out the contents of a file. But if I want to just get the first lines of a file, you can type head test. And if I supply the option 1, it will give me just the first line. So this command, head-1, is what we want to save in the variable. So let's open that up again. And here I'll include a $sign, and if you enclose what comes next in a pair of parentheses, you will actually save a command in this variable. So the command was head-1, and then the name of the file, which was test.txt. And just to make sure that this works, I'm going to echo out the result of the first line. And by the way, this is a neat little Vim trick. If you press Ctrl-N or Ctrl-P, it will cycle through a list of matches so you can autocomplete the next word. So I'm going to save that and quit with :WQ. And then I'm going to run that. And it will output the first line. Let's extend the functionality of the script a little bit. So let's open that up again. And what I want to do now is that I want to check if there is the letter A in this first line. I want to tell the user, and if there is not, I want to tell them that there was no match. So first of all, I'm going to create a variable called result, which will store the result of this search. The grep command looks through a file or a piece of text for the specified pattern, and then it shows you the lines that matched, or it shows you nothing if it found nothing. And I want to check if this grep command runs and doesn't find anything, I know that there has been no match. So I'm going to create a variable called result, open a $, open in parentheses, and then I want to type in the command that I want it to run. In this case, I first want to print out the first line, and I want to feed that into grep and just give it the letter A. Then I want to check if result equals an empty string, so like this, you open the square brackets, result, and then to compare strings, which is just text, you type double equals and just two empty quotes. And then there, right then. So if the result is just empty, we want to tell the user that we didn't find any occurrence of the letter A. Found nothing. And then exit out. So if I've written the script right now, we should be able to test it on the test file. So just to cat out the test file again and remind ourselves what's in there, we can see in the first line there is no occurrence of the letter A. So if I've done this right, it should tell us that there is no occurrence of the letter A. Let's run that now. Bash reader.sh. Found nothing. So then it works. So far we've just been working with pieces of text, and while these scripts are quite abstract and perhaps not very useful, so let's have a little practical exercise where I show you a script that you may actually want to use. Let's go to Vim and call it quickrename.sh. What I want the script to do is that I want it to take a number of files that the user gives it and then renames them with a set pattern and also appends numbers to the end of them. So let's begin by finding a list of the files that we want to work on. Now you've seen in all of these commands that I've typed, for example vim or bash, that you begin with the name of the command and then you give it some option or something to operate on. These options are called arguments, and they can be easily accessed from within a shell script. So to begin demonstrating that, I'm just going to echo out the first argument that we get. So echo, and then $1. $1 is the first argument, and then the next argument is $2, and the next one after that is $3, and so on. So if I just run quick rename now, nothing will happen because we haven't supplied any arguments. But if I were to supply something else, for example, beans, it will type out beans because that was the first argument that I gave it. So with this, we now know that we can access and supply options to our shell scripts directly from the command line. So I'm thinking that the first argument here is going to be the pattern that we want to name our files with. Instead of just saying echo $1, I'm going to create a variable called pattern where I will store this pattern that the user gives it. So pattern equals $1. So now the pattern variable captures the first argument that we give it. What I want to do next is that I want to go through the list of all of the arguments remaining, treat them as files, and then change the name of these files. So to do that, I can use a loop. A loop is basically a control statement that allows you to run a command several times. So to do that, I'm going to write for, which is the keyword to start a loop, and then I'm going to write the name of a variable that I want to have available inside of that loop. So since I'm going to be using a list of files, I'll just call it file because I think that's appropriate, but you can call it whatever you want. For file in $at. This $at symbol basically means every argument in the list. So I want to end that up with a semicolon and then write do. So you can think of this as meaning for every file in a list of arguments, do this. And before I start working with a file, I want to check that it actually exists. I don't want to run this command on anything that isn't a file or something that doesn't exist, because then I'll just get an error. So I'll add if -e, which is to check if a file exists. I'll add the variable, which is the file, and this $file will change every time the loop runs. So first it will go to the first file, and then we'll move on to the next one. So I can just do this for all of them. So if, then, and for now I just want to echo out the file. And this is good practice for all programming or scripting in general. You want to create your program or script in small increments and then test it and then keep working on it. It's generally not a good idea to write like 500 lines of code and then find out that it doesn't work. So let's just write this for now and test it before we move any further. So end that out with an FI. And then to close out the loop, you write done. So what this script should do now is that it should go through the list of arguments, check if it is a file that exists, and then just print out the name of the file. But first we're going to need some files to work on. So I'm going to create some by using touch, call it apples, oranges, and pears. And now when I run this quick rename.sh script on these three files, it should just print out the name of them. So quick rename, apples, oranges, and pears. And there we go, it types out the name. So let's go ahead and write the rest of the script. So what I want to do now, instead of just printing out the name of the file, I want to create a formatted string that I want to rename the file to. So before we start doing anything, let's make sure that we get this formatted string right. So this string is composed of two things. We have the pattern that we supply as the first argument, and then we have a number which should increment every time this loop runs. So to begin with, I'll just create that number, and I'll call it counter, and set it to 1 to begin with. And then every time this loop runs, it's going to increase the value of this counter. So let's first just echo out the result of what we're going to get. So I'll echo and include this in quotes, pattern dash, and then I'll include the counter. So this string that we have here should be what we rename the file to. And then for every time the loop runs, we need to increment the counter. And this is something that Bash is not particularly good at, but you can do basic subtraction and addition. It looks a little wonky though, so bear with me. I'm going to type counter, and then we're going to do a command substitution like this, and 2 parentheses, $counter plus 1, ending parentheses. Right, so now this should just go through the loop and print out what the file should be renamed to. And I'm doing this now just to check so I don't rename it to anything wonky. So now let's run this script. And if you remember that the first argument that I supply it is the pattern, so I'm going to call it my file, and then the rest of the arguments are the files to work on. So apples, oranges, and pears, like that. And it should now rename them to myfile1, myfile2, and myfile3. That's great, then we know it's working. So let's open that up again. And instead of using echo, we are going to move the file to this name. And remember now, if you type an underscore here, it's going to treat this as a variable name, in which case you will only get the number. So make sure you separate that with a dash or something else. So let's run that again, and I'm just going to press the arrow keys up this time to get the last command that I ran. And everything looks good. I'm going to press enter. And now if you run ls, we'll see what we have. And there you go. We have a file called myfile1, myfile2, and myfile3. So far, the way we have been running these scripts is by typing the name bash, and then the script, and then whatever argument that follows. This is a bit verbose and perhaps not very smooth. There is a better way to work with scripts. So the way you can get around this is that you can mark a script as an executable file and then just type the name of the script, and Bash will execute it automatically. However, it's good practice to insert a line in the beginning of the script that explicitly states that Bash is the interpreter that should run this script, just in case there's something else that's default on your system. So first, I'm going to open up the script that we want to work with. In this case, I'm going to go to quickrename.sh. And then at the top of the file, I want to add what's called a shebang. So you add this pound sign and then exclamation point, and then you type in the path to the bash executable on your system. I'm not entirely sure what this is, so I'm going to go and check. So I'm going to check by typing in the command which bash. The which command tells you where bash looks for the specified command that you give it. So in the case of bash, we find it in /user/bin/bash. So I'm going to open up the script again, and I'm going to append the path there, /bin/user/bash, like that. In some cases, you may not have to do this, but I find it's a good practice to include it anyway. So now I want to give myself, the user, permission to execute this. If you run the ls-l command, you can see that all of these things here tell you what kind of permissions you have with this file. In all of these files, I have permission to read and write, but I do not have permission to execute them. I'm going to change that with the chmod command. So I'm going to type chmod u+x, which stands for user add executable permissions. And I'm going to do this on the hello.sh script. Now, if you run ls-l again, you can see that it is marked in green, and there's another bit here that says x. That means I have executable permission. I'm also going to do this for the quick rename script, u+x, quickrename.sh. So if I run ls-l again, you can see that this one also has executable permissions. So now instead of typing bash and then the name of the script, I can just type in the name of the script, or at least if I type .dash, which stands for this current folder, hello.sh, and then I can run the script, which is a lot easier than typing bash before it. But when you're using these scripts, you're usually not going to be in the scripts folder, and it's not exactly ideal to have to type out the entire path to the script just to be able to use it. We want Bash to be able to find all of these scripts in this folder regardless of where we are currently working. You can do this by editing the bash configuration file, a bit like you edit the vim configuration file. So I'm going to go back to my home folder, but before I edit that configuration file, I want to tell you how bash finds commands and executables on your system. So bash has a variable called path, which contains all of the folders where it will look for commands. So let's just look at what the path is right now. You can see all of these folders split up by colons is where bash will look for commands and executables. What I want to do is that at the end of this path, I want to add another folder, which is where we will keep all of our scripts, and then we can just type the name of the script and bash will run it, because it will already know where it is. So let's do this by editing the .bashrc file. This is similar to .vimrc. It's a file that bash reads through on startup and executes all of the commands listed within. On Ubuntu, you already have quite a lot of settings in this bashrc file. Most of these are pretty good, and I do encourage you to get familiar with them and structure your own bashrc file, but for now I'm not going to get into that. What I want to do is that I want to go to the end of the file by pressing capital G, and then opening up a new line and running the command export path, which means I want to export a environment variable, and I want to set that to what is already in the path, then add a colon, and then add the location of the scripts folder. In this case, it is /home /your username, in my case it's Joseph, scripts, like that. And now when we reload bash, or source this file, much like we did with the vimrc file, we should be able to run our scripts from wherever we are in the system, because they will be in our path variable. So I'll exit out, and then I will run the command source.bashrc, and now it will reload the path. So let's echo that out and see that we actually have the scripts folder. There you can see at the end, we have the path to where we have our scripts. And now, since I've given myself permission to execute the file and I have it in my path, I can just run it from wherever I am. So I'll just type hello.sh and it will run the script. There are, of course, many more things you can do with bash scripts, and it is a skill where you just keep on learning and discover new things as you go. But there is too much for me to talk about in just one video, so if you want to learn more and go more in depth about bash scripting, I would refer you to my bash guide that is linked in the description, which contains everything I've talked about here and more. It also includes some practical exercises if you want to work on some projects. But for now, I think this will suffice as an introduction to bash scripting, and I want to thank you for watching, and I'll see you in the next video.